we're gonna get going. Thank you very much for coming. Welcome, everybody. And my name is Roberto Llano. I'm the Assistant General Manager with Sweetwater Authority. And I want to introduce Justin Brazil, our Director of Water Quality, who will be leading us through the presentation tonight. And we have in the room also our communications team, JPW. Thanks for coming and for us down here. And well, thank you for deciding to spend your evening with us, a couple hours at least. Want to recognize Angel from Senator Padilla's office. Thank you for coming. We're expecting Mayor Morrison as well, and Councilmember Diaz Yamani. They should be coming in a bit, but can I get the next slide, please? You got it. All right, so just want to set some ground rules tonight. So today's a public discussion, not a debate, so everybody should have an opportunity to speak, and we should all listen and respect other points of view. Right? Next slide. Tonight we're going to go through what is PFAS. That's the purpose of the meeting. EPA regulations, PFAS testing results for Sweetwater Authority, potential solutions, and public comments from anybody has questions. Feel free to ask any questions if you have them as we go forward. We're trying to make sure that we're very open and trying to make sure that we capture and answer as many questions as we can. So with that, I think I'm going to turn it over to Justin to take us through this presentation. Again, we'll all be available for questions through the presentation and then after. Thank you very much, Justin.
Thank you, Roberto, and good evening, everybody. Again, my name is Justin Brazil, Sweetwater Authority's Director of Water Quality. Thank you again for being here tonight. And before I start getting too much into speaking, we do have a very short informational video on PFAS that we put together that I'd like to play before I really jump into it.
You might have heard about testing regulations related to PFAS in water treated from Sweetwater Reservoir. PFAS is a complicated topic and an issue that water providers across the globe are facing since this substance is so prevalent in our society. These forever chemicals are found in everyday items like firefighting foam, cookware, clothing, and food packaging. They are slow to break down, and when discarded, they can enter our environment and water supply. Sweetwater Authority is in the process of conducting 4 tests over a year to better understand the situation and confirm exact levels of PFAS in the water supply. This will give the authority information to evaluate potential solutions. While compliance with the EPA's new guidelines isn't needed until April 2029, here's what we're doing now to address this issue: expanding testing and monitoring, determining the sources of PFAS, engaging in public outreach. You can get involved by visiting our PFAS education page, joining a public workshop, or contacting us with questions. Together, we'll protect our water supply and your public health and safety.
All right, well, thank you for that. So just a little bit of reiteration of some of the information that was in the video. So PFAS, a long acronym for per and polyfluoroalkyl substances. So these have been manufactured in the world or in the United States since probably approximately the 1940s. And they've been used in a variety of products, fast food packaging, chemicals used in stain-resistant carpet, wrinkle-free clothing, firefighting foam for airports, and cleaning products. And so, these PFAS chemicals, they often are also called forever chemicals. And there's a reason for that, because these chemicals are made up of the bond between carbon and fluorine, and it's one of the most strongest bonds in nature. And so that works great for all these purposes, non-stick cookware, stain-resistant carpet. But the problem with it is, because they're so good at not being able to be broken down, those forever chemicals, that they are persistent in our environment. And they can get into our environment, and including our water. And so, for example, PFAS has been disposed of for decades in landfills. And so we throw away products as a society in landfills that contain PFAS, and then that PFAS that's in the landfill can percolate into the groundwater supply, and it can run off into surface water supplies. And then there's also a lot of other exposure routes, as far as consumer products that we've used for decades. And so, one thing I should mention is, PFAS is found in drinking water, but it's also found, in other areas, for example, air, and you can come into contact with PFAS in more than one way. Water is just one exposure route, so through consumption and also through the air or other exposure routes. And so the graphic here from the EPA's website shows just how persistent PFAS is in the United States. And so the legend on the left there shows that this is showing all sources where PFAS has been found in water, in biological tissue, air, soil, and sediment. And then switching to the next slide, showing just how persistent it is in water. And this is more than just drinking water, it's also water, wastewater discharges, but all water related. So, those are all tied together, right? Because if PFAS is in discharges, it can also make it into drinking water supplies as well. And so solving PFAS in the United States is estimated to cost upwards of $200 billion. So it's a big problem to solve and also a very expensive problem for us to solve as a society. And so the United States Environmental Protection Agency, as well as the state of California, have taken significant steps to address PFAS. And California does have one of the most comprehensive PFAS testing and monitoring programs in the country. And so in fact, the state has been issuing monitoring orders for PFAS chemicals for quite some time. And Sweetwater Authority has been monitoring groundwater supplies since 2019 under these monitoring orders, under several of them. And more recently, Sweetwater Reservoir was added to the monitoring order as well to be tested for. Now, back in April, the EPA released a new, what's called National Primary Drinking Water Standard for PFAS chemicals with 6 what are called maximum contaminant levels, or MCLs. And those are enforceable standards for PFAS that will go into effect in 2029. But there's a phase-in period, so the regulation was released in April 2024. The first part of it is what's called initial monitoring. So water utilities have until 2027 to perform 1 year of quarterly monitoring. And now what that does is it lets the utility know what levels, if any, of PFAS they have in their water supply, which is important, right? So that we can plan for treating for PFAS or remediating if we need to, mitigating for it, I should say, in the future in 2029 when these come into effect. But it'll also set the monitoring schedule that's required for an agency depending on where those levels fall. And so under another regulation by the EPA, which is called the Unregulated Contaminant Monitoring Rule that water utilities are required to participate in, we are also monitoring for PFAS under that rule. And so that's also satisfying our initial monitoring requirements under this PFAS regulation. And so Sweetwater was scheduled to start this UCMR monitoring in October 2024, at which time we also concurrently performed Q1 monitoring of this initial monitoring requirement for PFAS. And I'm sorry, one thing I should mention here, if I go to the next slide. So the maximum contaminant levels, they're set at different for each of the different PFAS compounds, but the lowest level being set at 4 parts per trillion. And so what does 4 parts per trillion look like? So 4 parts per trillion would be equivalent to 1 drop of water in 5 Olympic-sized swimming pools. So 5 times 660,000 gallons is what that would look like, 1 drop in 5 Olympic swimming pools. And so just to give a kind of a brief overview of the evolving regulatory framework, if you will, of PFAS over the last 16 years. So back in 2009, the EPA had issued what are called health advisory levels. So non-regulatory, non-enforceable, health-based advisory levels for 2 of the PFAS compounds, which are PFOA and PFOS. So 2009, and at that time, they were set for 400 parts per trillion and 200 parts per trillion. Then fast forward to 2016, and they lowered that health advisory level to 70 parts per trillion, and that's a combined sum of PFOS and PFOA. The sum of those together would be at 70 parts per trillion, is where they set the health advisory level. And then now we fast forward to 2029, when the new standards are enforceable, but they turn from health advisories now into enforceable maximum contaminant levels going into effect in 2029. But something to point out here is just kind of the evolution here is For PFOA, for example, we went from 400 to 4, so we're looking at a 100 times difference now in from an advisory level to where this compound's going to be regulated at. So a lot of change there in 16 years. And similarly for the reporting levels for what the analytical methods that we run to test for these chemicals. So what's a reporting level? So if something's detected above a reporting level, it's reportable. If it's detected at a level below the reporting level, then it's considered not detected and it's not reportable, because every analytical method has a level of certainty, and at a certain level, the level of confidence in the data drops off, and so they set what are called reporting levels, or sometimes referred to as minimum reporting levels for everything that a water utility is required to monitor for. And those have changed quite a bit too. So in 2012, it was 40 parts per trillion pure PFOS and 20 parts per trillion for PFOA. And then in 2016, and going into the current time, those were now dropped down to 4 parts per trillion. So really what that means is we've made advancements, right? We've made advancements in our ability to detect PFAS as well. So now we're looking at PFOS at a level 10 times lower than we were really just a few years ago. So in some cases, there may be some utilities in the United States or elsewhere that may have thought they did not have PFAS chemicals in the water, but now that the analytical methodologies have improved, now 10 times lower, when we're looking at something smaller under the microscope, we can actually see it. And so we talked about the Environmental Protection Agency and the maximum contaminant levels going into effect in 2029. However, in California, there already is some existing regulatory framework in the form of what's called a response level and a notification level. So I'll start with notification level. So that's the lesser of the two. So notification level is, again, an advisory level that's set by the state of California. And if you detect something above that health-based advisory level, then the requirement is you need to notify. And so that means the purpose of the notification means notify the governing body of the water agency and any other jurisdictions that it serves. And so before I jump into the coming slides and some data, you may have heard that Sweetwater did do notifications back in December for notification level exceedances for 2 of the PFAS compounds. So our Q1 monitoring in October came back in November, and we became aware that we had exceeded the notification level for 2 of those. And so in December 2024, we did do our public notifications on that. Now, response level is a little bit different. It does have the same notification requirements to governing bodies. However, there's a couple different subtleties here. There's also a lot of additional notification requirements on top of just notifying governing bodies. There's a lot more public notification involved in that. But also, the utility has to contemplate whether to utilize treatment or blending or take the source offline in order to bring the treated drinking water down below the response level. And so the table here shows a summary of all the PFAS chemicals that were detected during Q1 and Q2 sampling. Now, not every PFAS chemical in this table necessarily has a regulation associated with it, but under the UCMR rule, we're testing for 29 PFAS compounds. That's the requirement. And so what's presented here is everything that was detected above the reporting limit when we ran those tests, and so that's what's shown here. However, not everything necessarily has a future maximum contaminant level or an existing notification or response level in California. But during Q1, we exceeded notification levels for the 2 at the top that are colored there, the PFHXS and the PFOA. On January, last month, we performed our Q2 monitoring. During Q2, the data came back a little bit different. We're still exceeding a notification level for the PFHXS. However, for the PFOA, we're now at 11.4 parts per trillion, and the California response level is at 10. So we just exceeded that, and that puts us into that response level category. However, we are currently in conversations and engaging our regulatory body, which is the California State Water Resources Control Board, Division of Drinking Water, and we're working with them to seek official direction on next steps to take regarding that data. And so the next few slides here are just going to show our Q1 and Q2 data for the different PFAS detected in relation to California response notification levels and the 2016 federal health advisory levels. So the first slide here showing the PFOA at 9.4 parts per trillion, and then 11.4, showing the exceedance of the response level. And then for PFHXS, showing that we 6.7, 9.4 parts per trillion, but still below definitely above the California notification level, but well below the 20 part per trillion California response level. And so the authority is collecting a confirmation sample for the Q2 monitoring. And so I expect we'll be collecting that sample soon, hopefully this week, and then have data in probably about 2 weeks as typical standard turnaround time for a contract laboratory. And we're gonna keep monitoring and keep the public informed of the results as we get new data and new information. However, very importantly, we're also looking at considering the options for building a treatment facility to treat for PFAS in the future, because the authority wants to be in full compliance with these new maximum contaminant levels by 2029. And there are best available technologies that are already out there that are approved for treating for PFAS. And so we do understand that the public has concerns about their safety and PFAS. There are risks with PFAS, and that's why there was a maximum contaminant level established for them, because there are health risks associated with it. It is widespread in our environment. Water is one source of being exposed to PFAS, but also through other products in our environment, and even the air, we are also exposed to PFAS. The Environmental Protection Agency does have, there's on some few further slides, there'll be some links, but they do have information regarding the purchase of water filters, or oftentimes called point-of-use devices, that are designed to reduce PFAS levels. It's very important, as the EPA says, to make sure that any products that are purchased to remove PFAS at the faucet are in compliance with the ANSI 53 and 58 certifications. And it's very important to follow all manufacturer guidelines, and especially operation and maintenance and replacement of those filters. And on the slide here, I know we're going to publish these on our website, but there is a QR code, and Suzanne back there from our communications consultant has flyers back there with the information, and so there are links and fact sheets on the EPA's website specifically for those point-of-use devices. And so kind of looking at where we're at right now, so under this initial monitoring period, we're required to have 4 quarters of data. And so we're halfway through that right now. We have Q1 and Q2, and we're scheduled to sample again for PFAS in April, Q3, and July, Q4 of 2025, to build the full picture and really understand where we are. And an overall timeline of how we got to where we are today and where we're going. So, and again, in April 2024 is when the National Primary Drinking Water Standard was issued. In October 2024, the authority performed its first quarter of monitoring. In January 2025, actually let me back up, in December, we performed notification for the notification level exceedances for Q1 monitoring, and also started engaging the public and doing a lot of outreach to inform the community of where we're at. January 2025 was our Q2 monitoring and results. And then in April and July of 2025, again, we will be sampling for our Q3 and Q4 to complete the entire year as required under the new regulations. And then advancing a few more years, be in full compliance with the regulation by 2029. So it's a very critical moment to plan right now, because there's significant costs associated with installing treatment for PFAS in the order of millions of dollars. Advanced water treatment technologies like granular activated carbon or ion exchange would likely need to be installed. And it's not just a capital investment, there's also significant costs moving forward with the operation and maintenance of these systems. Now switching to an alternate water source like imported water through the aqueduct system could be done, but it would add significant costs to the authority. And so as far as our outreach campaign, so on January 28th, we had a community advisory working group at our Richard A. Reynolds groundwater desalination facility where we engaged the public. And then we're here tonight at the National City Library having our first community workshop, and then we're gonna have another in Chula Vista on February 13th, and then at the Bonita Sunnyside Library on February 19th. How can you get involved? On our website, we do have a link, sweetwater.org/PFAS, with additional information on PFAS. We have an email list that you can sign up for that we encourage. There's also an email, pfas@sweetwater.org, where you can ask questions that you may have regarding PFAS, and we're committed to getting back to all inquiries within 48 business hours. We have a PFAS hotline, and then, of course, like you are today, you can be here and be engaged with us and attend a meeting. And with that, I'd be happy to answer any questions.